Okay, good evening, students. Today we discuss about the databases. Okay, so databases, it's like DBMS, database management system. It's a software that is used to how to manage the data in the of storing in a database. Okay, so it is doing search as entity and relational model keys, relational algebra operations, the transactions, and then concurrency control file operations. Okay, these and all doing the more operations are uh, using in the software of that databases. Okay, so the next, what is database? Okay, so the data is a collection of distinct small unit of information, isn't it? Okay, we take the example in the student database. Okay, this is the database name, student database, employee database. Okay, in that of banking system database. Okay, what is the name in that of database? Okay, the related data have to be stored in one data collection. Okay, that is called in a database. Okay, this is a storing of information in a computer system. Okay, another that the word is a distinct small unit of information. Okay, so variety of forms of the data have to be stored. Okay, like that of text, numbers, media, video. Okay, so these and all data I have to store in a pieces of paper or electronic memory. Okay, so the pieces of information, it means we have to store the information. That the information is translated into the in a efficient manner of processing. Okay, so this data is interchangeable. Okay, so that is called in a data in a database. Okay, we take in the student database. Okay, the database is organized the collection of data, isn't it? It can be easily accessed and managed. Okay, in that of database, we have to organize the data is like tables, rows, columns, and index. Okay, we have to find all the related information or relevant information to be stored such like that of tables, rows, columns. Okay, so here in that of database, given in that of syllabus, so ER model, relational algebra, the tuple calculus, SQL integrity constraints, normal forms, file organization, and transaction concurrency control. Okay, so before that, I given small introduction about what is data, what is DBMS, isn't it? Okay, so we take an example in that of student database. Okay, we can store all the information of student like that roll number, register number, student name, student date of birth, student address, mobile number. Okay, these and all have understood in the data in the database. Okay, so in our college, we have to maintain also in the student database, isn't it? Okay. So all the informations are stored in a small unit of uh, using in a computer system. Okay, so that is called in a database. Okay, how to organize, how to manage the using of in the software. Okay, so the DBMS is a software for storing and retrieving how all the users data to be considering using in some security manner. Okay, so in that student database again we have to splitted or managed in other some other way of data is called a database. Okay, able to understood. Okay, so the next we have to store in the brief information of student database. We can store like that of course database. Okay, so in that of course database, student roll number, register number, the semester wise marks we have to store in a single database. Did you able to understood? Okay, so this is a small introduction and then very clearly know that of what is data, what is database. Okay, in the of in database are available more databases, that is MySQL, Sybase, Oracle, then SQL Server. Okay, nowadays mostly used in that of SQL Server, MySQL, isn't it? Another that of Oracle database. Okay, in that of using in a RDBMS concept. Okay, we stored in a structured query languages. Okay, literally we are discussing about in a SQL. Okay, so this is a what is data, what is database, how to organize the data in a database system. Okay, the next more databases are there. Okay, that is centralized database, object oriented database, hierarchical database, network database. Okay, these and all more databases are there. Okay, under the structure of the database, they classified in the data models. Okay, the data model is the modeling of the data. Okay, how the data is organizing, how the data is storing and retrieving the data from the database in the system manner. Okay, so that is called data model. Okay, so in that of data model, only given data description, data semantics, and the consistency of constraints data. Okay, what is data description? What is the data given the meaning? Take example, the roll number, register number. Okay, then data semantics. What type of data we have to store? Then in which data, what type of format? That is, that format is stored in the limits of data. That is called the constraints of the data. Okay, the constraints means that is a condition. So that it provides more constraints. Take example in that of keys, foreign key, candidate key, primary key. Okay, so these are all given the data models when describing the data of each unit of data. Okay, so under in that of data models, classified relational data models, semi-structured data model, ER model, object-based data model. Okay, so given this data model, in your syllabus given ER model, that is entity relationship model. Okay, so the sorry, entity relationship model is a software engineer how to design the database using in some of the metrics. Okay, that is called the ER model. Able to understood. Okay, So ER model is a software engineering, so given the abstract of the data. It's very important. Okay. Okay. So we take an example in a student database. Okay. What data we have to store, what are the data we have to manipulate from storing and retrieving the data in a student database. Okay, that is called abstract of the database. Okay, so in that abstract of the database, given the what is the starting data, what is the end data, how the data is stored in the form of tables and then rows. You will understood. Okay, that is a ER model. Okay, so in that of ER model, more relationships are there. Okay, so very important in that of in the ER model, that is entity. Okay, so the entity means uh, anything we have to describe in a real world, nothing in that of object. That is called the entity. Okay, so it is object or distinguish between the data, whatever in it. Okay, so all the entities are have the same set of attributes, then also have a key, as the keys are mapped into the relation. 1 to 1, 1 to many, many to 1, many to many. This is the relationship between those data. So given in that of ER diagram, the entity have classified weak entity and a strong entity. Okay, so then attribute have classified in that of key attribute, composite, multi-valued derived attribute. The relations means how the data is related to the attribute of 1 to 1, 1 to many, many to 1, many to many. We will understood. Okay. So first of all, what is a weak entity and a strong entity? Okay. So the entity in that of another is a object. Okay. The weak entity, how the entity set is strongly relationship between of those data. Okay, that is strong entity set. Okay, the weak entity set here in the PPT, the relationship of 1 to 1, 1 to many, many to 1, many to many, isn't it? Okay, here. Okay, so in this structure also described of the entity set. Okay, the weak entity set, an entity is set not sufficient. Okay, that is not suitable for the relationship. Okay, so that type of data is called in a weak entity set. Okay, in that take example employee, employee to manager. So the manager, how to the relationship other entity set. In the top diagram or entity set not described, that is a weak entity set. They cannot described. Okay. The next one is an attribute. Okay. So attribute is a property. Okay, how the properties are coincide in that of in a domain. Okay, take example in that of student database. Okay, in that of student database, given the student name, isn't it? Okay, the student name is an attribute. Okay, in that of attribute we classified again first name, last name, middle name. Okay, so these and all further prescribed in that of composite attribute. Okay, so there are many attributes are there. One of the attribute in your domain, that is a composite attribute. So one component have derived in another component, that is called composite. Okay. The next one is a derived attribute. This derived attribute is derived from the values of other related attributes or entities. We take example date of birth. Okay, DOB, the date of birth is one of the attribute. In that attribute we derived from or calculate an age. Okay, then also example for home loans. Okay, it's a derived attribute. A monthly EMI can be calculated through from the derived attributes. Okay, then single valued attribute. One attribute given one value, that is only one value. Okay, so that is so called, that is a unique value. Okay, example employee number, also in your student register number, roll number, isn't it? Once you assigned one student of one roll number, okay, that roll number cannot assign to some other students. Okay, if it is the same name have in a two different students. Okay, so that's why we have to identify using in that of roll number and the register number. So we have to avoid the confusion, isn't it? Okay, that is single valued attribute. So also employee. So any one organization, okay. So same working of employees, isn't it? How to identify only in the employee number. Okay. Then multi-valued attributes, so more than one values are having. Okay, example mobile number, the phone number. Okay, this and all called multi-valued attribute. So in that attributes very important is a prime attribute. Okay, that is in a primary attribute. That is the part of the some candidate keys are like there. Okay, also non-prime attributes are there. Okay, it's not a part of the any candidate key, that is called non-prime attributes. Okay, so the relationship in that of we have to maintain the one to one to many, many to many, many to one. Okay, how the mapping coordinalities are associated via inner relationship, that is called inner set of relationship set or in between of the entity sets A and B, that is called a mapping coordinality. Okay, so then given the example in that of employee and that of employee ID card, okay, we have to use it in that of identity. Okay, the one-to-one relations of using. Okay, one-to-many relationship is the student have attended test. Okay, then many to many, also many students attend the many test. Okay, so these and all. Then specialization, generalizations also using in that of ER diagram. Okay, so ER model. So this is the theory of that given short intro. Okay, so now we take the question. Which of the following is used to represent the supporting many-to-many relationship of a weak entity set in an entity relationship diagram? Okay, one of the gate question, the ER model. Okay. So what is the given question for that? How to represent? Okay. So in the ER diagram, how more sheets are we have to represent? Okay. Already I told that. Okay. ER model is a purely diagrammatic representation, isn't it? Okay. Diagrammatic representation. Okay. So ellipse, square, rectangle, okay, lines, these are all using. Okay, so here in that of the relationship diagram, how to represent in a weak entity set of many to one relationship. Okay, so the many to one relationship. Okay, so this is a easy question. Okay, we have to represent given the option diamonds with a double border or border, rectangles with a double or bold border, ovals of double or bold border, ovals that contain underlined identifiers. Okay, so the answer is A, diamonds. Okay, rectangles only represent the attributes. Okay, ovals shape is not prescribed in a ER model. Okay, so option A, option B, anyone is a we choose. Okay, so diamonds with a double or bold border is the answer. Okay, again I told that which one of the following is used to represent the supporting many to many relationship of a weak entity set in an entity relationship diagram. Okay, so the diamonds with a double or bold border. Okay, so the next question is a very important question. Okay, and also it's a very simple question, but the given paragraph is very confused. Okay, so let E1 and E2, two entities are there in an ER diagram with a simple single valued attributes. R1 and R2 are two relationship between E1 and E2, where E1 is one to many, R2 is a many to many. R1 and R2 do not have any attributes of their own. What is the minimum number of tables required to represent the solution in the relational model? So let E1 and E2, first point is E1 and E2, the two entities, okay, given the single valued attributes. Second point, R1 and R2, two relationship between E1 and E2. Okay. So third point we noted R1 is one to many, R2 many to many. Okay. Another that given R1 and R2 do not have any attributes of their own. ஓனாது எந்த அட்ரிபியூட்டுமே என்னது வச்சுக்கல. So what is the answer for given the representation with a minimum number of tables required? Okay, so here at E1 and E2 the single valued attributes, isn't it? Okay, single valued attributes means is a strong entities of relationship. Okay, so the many to many relationship, we have to convert, we must create one separate table. Did you able to understood? Okay, again I told that okay, we have to create a many to many relationship of given the relation of R2, isn't it? Okay, but we must convert the separate table by giving the primary key. Okay, so by take E1 is a primary key. Able to understood? Okay. So the primary key of E1 and E2 also treated as foreign key. Okay, so E1 is a primary key and then E2 as a foreign key. Okay, so one to many relationship, that is R1. Okay, given the question, so we have to must transferred many tables. Okay, the primary key of E1 and then foreign key of E2. Okay, so we create first E1 and E2. Okay, the first table is E1. So the attributes A1 and A2. Okay, we take example 1, 3, 2, 4, 3, 4 like that. Okay, that is a data. Okay, the next I create another one table, that is E2. Able to understood? Okay. So E2 is another one table. Okay, the relationship set is satisfy the attribute of P1 and B2. Okay, so B1 and B2 also inherit the data from the relation E1. Okay, that is A1. A1 is a primary key. Okay, here A1 is a primary key, they also treated as a foreign key. Okay, for how to the relationship converted into many to many relationship of R1. Okay, we have to combine in a R1 and R2. Okay, using in a union operation. Okay, so A1 and B1. A1 is a for primary key, the B1 is a foreign key. We have to retrieve the data from the entity relation of E1 and E2. Okay, E1 and E2 union R1 R2. Okay, so we have to combine this the relationship. Did you able to understood? Okay, so we must minimum table that means already created 4 tables. Okay, so yeah, we cannot create another one table of A1, A2, B1, B2 because of that A1 and B1 minimized of many to many relationship from the attributes of relation R1 and R2. Okay, so we need only for another minimum 3 tables. Able to understood? Here in that answer is B. Again, I told that we create a 4 table E1, E2. Okay, the relation of R1, R2. Okay, E1 and E2. Assume that we created 2 attributes A1, A2, B1 and B2. Okay, A1 and B1 is a primary key and then foreign key. Okay, so automatically we delete the data of duplicate. Okay, very important in that of database is a remove duplication of data. Okay, so automatically remove the duplication of data because of that here in that E1 is a primary key of A1. E2 is a B1 of foreign key. Okay, so automatically delete the duplication of key. Okay, we create only in the 3 tables. Did you able to understood? Okay. So the next question, consider the ER diagram. Okay. So in that of ER diagram, given in that of already we discussed the previous question. Okay. Previous question given in that of tables in a minimum relationship. Okay, here in that of in a ER model. Okay, that is ER design model. Okay, so take in that of question Consider the following ER diagram. Okay, so M1, M2, M3, P1, P2, N1, N2. Okay, how to minimum the number of table needed to represent MN, P, R1, R2 is. Okay, so M1 in that of M table. Okay, so that is primary key. Here in the P table represent P1 is a primary key. N represent the N1 is a primary key. Okay, the R1 R2 are a relationship. Okay, so here in that of used in a participation. Okay, using in the total participation. Okay, so all the data are involved in the R1 and the R2. Okay, so the MP is a strong entities of relationship. It represented by a separate tables, that is M, P and N. Okay, the three separate tables are given. Okay, so the many to one or in one to many relationship will be used, that is in a total participation. The double arrow, double lines of using in that of total participation. Okay, students. Okay, so we must adding another one attribute of primary key. Okay, so here in the top and the tables M, N and then P, isn't it? Up M1, P1 and then N1. Did you able to understand how to modify the in the top primary key using in the top relationship? Okay, so here in the top, no down n table, that is called weak entity because the double rectangle, isn't it? Okay, double rectangle means is a weak entity. Did you able to understood? Double line is representing the total participation. Okay, so we have to modified again in the top P table. Okay, so the P table here P1 and P2. P1 is a primary key. Okay, how to here minimum number of tables we can create. Okay, so first the M table M1, M2, M3. Another one we have to represent is a P of P1. P is a P table. Okay, P1 given the primary. Okay, so we have storing the data and retrieving data from the P table in a P1. Okay, so we create a table of M of M1, M2, M3, P1. Did you able to understand? We take example in the student database. Okay, M. Okay, so M1 is a register number, student name, date of birth. Okay, so the P table is a course name. Okay, so course name in that of how to identify the student data. Okay, so using in that of P1. P1 is a course name. Okay, so CSE or IT like that. Okay, P2. Okay, course number. Okay, so we have to exchange. Okay, P1 is a course number and then P2 is a course name. Okay, 01, 02, 03 like that. Okay, so N. N is அப்படின்றது is a we take CGPA in the tough, the first and second sum marks in the tough. Okay, so how to minimize the table? Okay, so first M table, the register number 001 11. Okay, so the P1 course name. Okay, so take example 104. Okay, then another one here in that of CGPA. Okay, 7.5, 8.3. Okay, very note it down. Is okay, n table is in a weak entity. We have to convert using in the minimum of tables. Okay, how to? So n of P1 comma N1 comma N2. Okay, so we can retrieve the data from the P table. Did able to understood? Okay, so the same answer is here in that of third question, that is answer is 3. Okay. Mostly the gate questions are like that given in the format. Okay, so the next, the fourth question, consider the data given in the above question. Saying the correct attribute set for one of the tables, so for the correct answer to the given above questions. Okay, because these questions are the previous question same, but one difference is there. Okay, what is the difference? Okay, so the previous is questions how to minimize the table. Okay, but here in the top, create a attribute and then table. Okay, but how to organize the data without duplication? Okay. You tell that ma'am, M1 is a primary key, P1 is a primary key. Okay, we have to when creating a table and then put the data, automatically duplication is avoided. Okay, but not the 100% of data is deleted or avoided. Okay, how to manage? So this question is given the solution of the duplication of data. Okay, because of that we have to convert in the diagram to strong entity. Able to understood, because n is a weak entity. Okay, so we have to convert in a strong entity. Okay, so we modified the strong entity means the P1, P2. Another that we create a n of P1, comma N1, comma N2. Okay, it able to understood. But how to minimize the table of attributes, the many to many relationship of attributes. Okay, the answer is A, M1, M2, M3, P1. Okay, the previous question is, the answer is like that of n comma n of P1 comma N1 comma N2. Okay, so we represent the weak entity. Okay, here converted into strong entity. So the answer is M1, M2, M3. So M is M table. M1, M2, M3 also we have to integrate the data from the another weak entity, that is a n table. Okay, so represent only in a P1, that is a course code. Did you able to understood? Okay, so the next slide, the ER model, they consist of entire types. Okay, consist of entire types A and B. These connected by the relationship or which does not have own articles. Under the following condition, it can be relational table for R is merged with that of A. How to merge it with that of A? Okay, so how to merge it in that of we can use many to many relationship. Okay, because of that all the participants participations are related to using in the merged tables. Okay, so many tables are using in a total participation. Okay, so partial participation also is suffered in a weak entity. Okay, so total participation relationships is merged using in the top side. Okay, able to understood here in that of using total participation. Okay, so the answer is C. Okay, so the I read out the first option, relation R is one to many and the participation of A, the relation R is total. Option B, relation R is many to many and the participation of A, R is partial. The relation R is many to one and the participation of A is R is a total. the relation or the many to one, the participation of or is partial. Okay, so already I told that. Okay, any one relation we have to merge the data, it should be using in a total participation. Did you able to understood? Okay, so the answer is C. The relation R is many to one, and the participation of A in R is total. Did you able to understood? Okay. Okay, the ER model, the ER design, the concept is over. Okay. The next concept of given syllabus, the relational database. In that of relational database, so DBMS, we can storing the data and retrieve the data from the database, isn't it? Okay, so this is a DBMS. Okay, so we have to strongly connected through in a software using in a database. Okay, go for in a DBMS. Okay, that is a relational database management system. Okay, so relational, sorry. Sorry. So relational model is a completely uh, sorry, based on a relational algebra. Okay, the relational model is a completely based on a relational algebra. Okay, so it is a consist of more operations using operators. Okay, what is the main objective of in that relational algebra is a data retrieval. Okay, so in that of retrieval to represent execution of how the data organized using in a database. Okay, so in that of relational algebra, so using more programming models of database management system, that is SQL, MS SQL Server, Oracle, MS SQL, and then MySQL. Okay, the more modern database systems are using. Okay, how the data is organized using in the database is like in the relational query languages. Okay, so we must understand the SQL. Okay, so good understanding of using in a more query languages. Okay, example relational algebra, relational calculus. Okay, yes, okay. So what is relational algebra? Okay, using in the mathematical formation of how to retrieve the data from the database. Okay, so using some operations. Okay, the first of all here in the top, the data are stored in the format of tables, fields. Okay, how the data is organized and then how the data is managed. Okay, it's very important. Okay, so using in that of SQL constraints. Okay, the database normalization. Okay, these are the concept upcoming we have to discuss. Okay, the first of all, what is relational algebra? Okay, the relational algebra uh, using is a procedural query languages. Okay, so it is works on the all the relational model. We have to retrieve the data from the database and then using various operations using operators already I told, isn't it? Okay, so what are the basic operations are done in the relational algebra? First only selection operation. Okay, we have to select the operation of using in a tuples and then rows. Okay, it is satisfy the given condition. Okay, that is called in a selection operation. Okay, it is used, the symbol is sigma. Okay, then projection operation. Okay, this is specified columns are attributes from the given table or relations. Okay, that is called in a projection using in a by. Okay, then union operation, we have to retrieve all the data from the rows and erasers from the relation. Okay, it forms the relation from rows which are appearing in the either the both of the specified relations. Okay, that is or union yes. Okay, already you studied in DM. Okay, so or union yes. When the two conditions are satisfied, we have to retrieve the data from the R and S. Okay, that is union operation. Okay, then intersection. Okay, so opposite of an union operation. Okay, it's a represent in the both relation of R and S. Okay, then set operation. Okay, we have to find the tables in the one relation but not in the another. Okay, we can using in the minus or minus yes, that is set difference. Okay, Cartesian product using in a multiplication symbol. Okay, n1 into n2. Okay, we can represent the pair of tuples in each relation. Okay, or p equal to r into s. Okay, that is called Cartesian product or cross product. Okay, so this and all. So rename operation, we have to change the operation name. Okay, then that is the symbol of row. Okay, derived operations, the derived operations are using in that of one or more table we have to merge it. Okay, natural join, left outer join, right outer join, full outer join. Okay, so these and all using in that of relational algebra operations. Okay, so based on that of relation, okay, we discuss the question. The first question, the select operation in a SQL is equivalent to how equivalent to using in the select operation. Okay, the option A, sorry. The selection operation in a relational algebra, the selection operation in relational algebra except the select in a SQL, the duplication, the projection operation of using in a relational algebra except select at SQL. Okay. But the select operation அப்படின்றது is equivalent to what is select operation. Okay, we have to select the data. It says take example, select star from table name, select star from student is a database name. Able to understood. Okay, but we have to selection operation of using in a select table. Okay, we have to using in that of avoid duplicates of data. Okay, the next question we have to consider the tables T1 and T2. So in the table T1, P is the primary key, Q is the foreign key. Referencing R in the table T2 with using in on delete cascade, on update cascade. In that of table 2, R is the primary key, S is the foreign key. We have to referencing the P in the table T1. Okay, so also using in a null value. Okay, in order to, we have to delete the record, the row of 3, 8 from the table. Okay, we have to add a number of record during the insertion of operation. Okay. So numbers of additional record that need to be deleted from the table T1 is dash. So given the table T1, T2, PQ, RS, isn't it? Okay. The table T1, P is the primary key, so Q is the foreign key, isn't it? Okay. So the in that question, how we have to formulate the relation of, okay. So Q implies R, P implies S. Okay, because of that using in a primary key. Okay, so P R Q S. Okay, that is a primary key of avoid the duplication of record. Okay, then we take T1 of P. T1 of P, the third row, 237. Isn't it okay? Here in that of 1, 2, 3, 4, 5, 6, 7. Okay. So 1, 2, 3, 4, 5, 6, 7. Okay. So here 6, 7 here in that of 6 row. Isn't it okay? So given the question, we have to delete the record 3, 8 from table. Okay. So third row 2, 3, 7. Okay. So here eighth row not there, isn't it? Because of the delete the value was set as null. Okay. Therefore, when we delete 3 from the T1 and then T2 from the 3 will be null. Yes, because of that the eighth row also in the using in a cascade of null value. Okay. So again we have to take in a T2 table R and S. Okay. So the option A, we have to use in a zero entries, that is in a null value. Okay, because the third row also given in a null value, then eighth row also deleted. Okay, so the additional record we have to added using in that of T1 அப்படின்றது is not possible. Okay, so the numbers of additional record that need to be deleted from the table T1. Okay, T1 here in that of 0. Okay, the T2 table we have to must enter the value, because of that here the eighth row is already another null. Okay, so here the answer is 0. The next question, in SQL relations can contain null values and the comparisons with the null values are treated as unknown. Suppose all the comparisons with the null value are treated as false. Which of the following pairs is not equivalent? Okay. Null values. Yes, the comparison with the null value is treated as a null. Okay. So x equal to 5, not x equal to 5, x equal to 5, greater than 4 and x less than 6 where x is an integer. X less than 5, not x equal to 5, none of the above. Okay. So the answer x less than 5, not x equal to 5, because all the values of integer it should be minimum 5 and then greater than 5. Okay. So we take the integer of 0, the integer of 1. Okay, does not contain any smaller values. Okay, so the smaller than value of x less than 5 and then greater than b, it should be always true. Okay, so we have to set x equal to 5 is also in the comparison of true value. Okay, So we take the answer is x less than 5, not x equal to 5. Okay. The option A is also correct, but here in that of x equal to 5, not x equal to 5. Okay, it's not a meaning in that of option, isn't it? Okay, so x less than 5, not x equal to 5. The option is C. The next concept is functional dependency. Okay. Functional dependency means fully dependent the value of sorry, all the values of data, isn't it? So the dependencies of data okay. The functional dependency, the relationship of all the existing between the two attributes. Okay, it typically exists between the of all the primary key and non-key attributes. Take example, X implies Y. This is a functional dependency. Okay, if you take example student database, okay, register number, it implies all the Y side of student name, date of birth, address. Okay, X implies Y. Okay. So assume that in an employee table with the attributes employee ID, employee name, employee address, employee ID it implies employee name. Okay. So more types of functional dependencies are there. Basically trivial and then non-trivial dependency. So trivial dependency, A implies B. Okay, this is a trivial. Okay, so this B is a subset of A. That is called in a trivial functional dependency. A implies A, B implies B. Okay, so we take example in that of trivial functional dependency. Consider the employee table, employee ID, employee name. Employee ID, employee name, it implies employee ID. Here in that of employee ID is a trivial functional dependency of employee name. That is subset of employee ID, employee name. Okay, because of that employee name is the subset of employee ID. Indeed. So employee ID, employee name. So employee ID and employee name is the trivial. Okay. Non-trivial A implies B is a non-trivial dependency. Okay. So that is called non-trivial. So B is a not subset of A. அது வந்து subset is here in that of not subset. We take example, the same employee table, employee ID, employee name. Here also we add another one, date of birth. Okay, ID implies name, name implies date of birth. Okay, so student table register number implies student name implies date of birth. Date of birth implies address. Okay, this and all non-trivial dependency. Okay, so non-trivial dependency, we take the question, non-trivial dependency, employee name, salary, department number, and a department of department number, department name, address. Okay, which of the following queries cannot be expressed using basic relational algebra? Okay, we know that of algebra operations, okay, selection, projection, union, join operation. Okay, so here in that of question, department address of every employee. Okay, department here address of every employee. No, because of that employee table, department table. Okay, so we add the attributes of name, salary, department. Here the department table, department number, department name, department sorry, address. Okay, so not coincide. Okay, so because of that here the relation r and then r2 not mismatched. Okay, so the department address of every employee. Okay, so it's not a correct answer. The option B, employees whose name is the same as the department name, whose name is there in that of employee table. Okay, we have to using in a join operation. Okay, he cannot express the here in that of. Okay, then sum of all employee salaries. Yes, employee table here in that of having in a salary attribute. Okay, we have to find and then calculate it because a department table not dependent on in the employee table. Okay, so also we have to calculate the using in that of employee table in a salary. Okay, then option D, all employees of given department. All employees of given department. Okay, so we must using in a join operation. Okay, so also option D is not correct. Okay, so the option C, some of the all the employee salaries. Here in that of next question, consider the following relational schema. Students of roll number integer, yes name string, course number, registration. Which of the following queries are equivalent to this query in English? Find the district of all the students who score more than 90% in the course numbered 107. The first, using select district yes name. Okay, yes name where it's there student table. Okay, student as a yes, registration as called R. Okay, where R dot roll number and R dot course name. Okay, option 2 by name, then selection of using in a course number 107. Okay, here in that of easily we identify the option 2. Okay, using in a join operation. Okay, so no relation here in that of. Okay, the third option also uh, because here in that of using in a relation operation. Okay, wow. Then fourth is not is a relational algebra. Okay, so we have to use in a select. Okay, again I told that here in that of given the question is find the distinct names. Okay, so obviously we have to take the answer A, select distinct names. S dot name from the student as yes. Okay, registration as R where R dot roll number. Okay, the option answer A. Okay, the next, consider the join operation R with the relation S if R is a M tuples and S tuples the maximum of minimum sizes of the join respectively Mn and 0. Okay, so it is obviously given in that of relation. Okay, M plus N and 0 not there, M plus N and M minus N, M1 and Mn. Okay, it is initially the null value is represented as a 0. Okay, so given the relation R of W comma X and S of Y comma Z, the result of select distinct W comma X from R comma S is the guaranteed to be same as R provided R has no duplicates, yes, is an empty value. Okay. Okay, the integrity constraints. Integrity constraints means set of rules. Okay, that maintain the quality of the information. Okay, so that is called constraints. Okay, so in that of constraints, it contain the constraints value. Okay, then another one normalization. Okay, you know that well known. The normalization is very important in a database. Okay, to minimize the redundancy from the database using in the relation of relation set of relationship set. Okay, we have to use add, update, delete operations are done through in a normalization. Okay, so normalization concept is very important. Okay, then file organization. The file organization is defines how file records are mapped on the disk block. Okay, so the more types of file organizations are there. Sequential heap file organization, hash file organization, clustered file organization. Okay. So the B and B plus T's are very important when concept of using in the memory management. Okay. Okay. Thank you, students. So